All right, this is chapter 4 on exponential and logarithmic functions, and this is section 4.5 on logarithmic properties. So what we're going to look at are a bunch of different properties for logarithms, and the first one we're going to look at is the product rule for logarithms. So we're going to use it to simplify a logarithm of a product by rewriting as the sum of individual logarithms. So for instance, if we have log base b of m times n, we can convert that to log base b of m plus log base b of n. Now b has to be greater than 0 here. Now if the product m times n can be factored into prime factors, we want to do this prior to using the product rule for the logarithms. So here we're supposed to expand. And so what we're going to do is first we're going to make this into prime factors. And so that's going to be log base b of, well, a is 2 times 2 times 2, then times k. Well, now we can write this as a sum of 4 items. We're going to have log base b of 2 plus log base b of 2 plus log base b of 2 plus log base b of k. Okay. Now can we simplify that? Well, sure. If we notice, we have this plus this plus this. So we have 3 of those. So we can say 3 log base b of 2 plus log base b of k. And then that would be our final logarithms written into the summation instead of the product. Now, eventually what we're going to do is we're going to condense this, multiply it back out and go the other way and end up this way. But now what we're doing is we're expanding and going this direction. All right, what about this one? Well, this one, it looks like we can factor. So we had better do that first. So we have log of, well, it looks like we have a 2 we can pull out, times, we can pull out an x, times, and then what's left over is x plus 3. And we'll put maybe that into parentheses. So if we wanted to, we could write all of these in parentheses actually. And so now what we can do is we can break this into the 3 parts. So we'll just have 3 sums. So we'll have log of 2 plus log of x plus log of x plus 3. Okay. Now that's as far as we can go. We can't break that down any further because we can't factor x plus 3. And so when we get to that point, we just stop and we say we're done with that one. All right. So now we have quotient rule. So instead of doing the product rule, now we're moving to quotient. And so here we're going to use this to simplify logarithm of a product by rewriting as a difference of individual logarithms. So first we're going to rewrite this as m divided by n, or we can take that n to the -1. And either way we want to look at this, what happens is we're going to take the log of this one minus this one. Okay, so we're going to basically rewrite the quotient as a product, and then we can go ahead and do our subtraction is what's going to happen. Well, first, this one looks like we have to do some factoring. Okay, so, well, that gives us log base 2 of, well, it looks like we can pull a 7, an x, and x plus 3 out in the numerator. And here we have a 7, an x, x minus 1, x minus 2. And so we start with this. Now, the key is we can cancel. Our 7 cancels that 7, that x cancels that x, and so really we just have these 3 items left, okay? And so when we do that, what does that give us? Well, it gives us the log base 2 of x plus 3 minus, and then we have the log of x minus 1, and then plus the log of x minus 2. And so what we're looking at, that is, this is the product, and so we can do that log x minus 1 plus log x minus 2. But this quotient, when we take the quotient, we do a subtraction. So we'll take that first one, the numerator, minus the denominator, and that would be what we get. But what else could we do? Well, we could go ahead and distribute that negative through, and we'd have log base 2 of x plus 3 minus log, and I think I forgot my base 2's there, base 2 of x minus 1 minus log base 2 of x minus 2. So what we could do is we could go straight to here if we wanted to, because we know it's going to be the log of x plus 3 over the x minus 1 and then minus the x minus 2 parts. Or we can go ahead and say, okay, well, we're subtracting, and then that's the product in the denominator, so they're adding, and then we distribute after that and we get the subtracting. So kind of depends on how you want to look at that. And so basically we're just converting our quotient into the subtractions. All right, so here we're going to use the power rule for logarithms. And what we need to do is simplify by rewriting as a product of the exponent times the logarithm of the base. So we have log base b of m to the n, so our power. What we're going to do is take that power and bring it down in front. And so we put it here, and so we've taken that n, that's the power, brought it down in front as the product now, so n times log base b of m. So that's what we're going to do with these. We're going to do something similar to that. So here we're going to take that 2, bring it down in front, and so that gives us 2 ln of x. Now this one, we kind of have, a couple things we can think about doing here. We can rewrite this one as ln of x to the negative 2 and have that. Or, we could take the ln of 1 minus ln of x squared and do it that way, and we get the same thing. So let's first do it this way. And so this gives us a minus 2 ln of x. Or, like I said, we could take the ln of 1 minus, and then we have the ln of x squared. And this then becomes, well, ln of 1, guess what? That's 0, minus, now we can bring that 2 down in front. We have 2 ln x. And guess what? We get the same thing no matter if we went ahead and made this into, x to the negative 2, or we used the quotient rule and split it up into ln of 1 minus ln of x squared, then used the power rule and brought the 2 down here, and either way, we get the same answer. All right, so let's do some expanding here. And again, we can do this one two ways. What we could do is, one way, we could say, okay, well, let's bring that z to the 4 up to the top and say, well, now this is log of x squared times y cubed times z to the negative 4, which then is going to be the log of x squared plus the log of y cubed plus the log of z to the negative 4, which then we can use our power rule and bring each one of those down, and we get 2 log of x plus 3 log of y minus 4 log of z. So that is going to be our final answer. And the other way we could do that is we can just use our product and quotient rule starting from the very beginning and say, okay, well, this instead is going to go to log of, well, we have x squared plus log of y cubed. And then we can say, well, now we're going to subtract log of z to the 4th. And that gives us 2 log x plus 3 log y minus 4 log z. Okay, because again, we're bringing those down, and when we do that, we get this. And if we notice, we have exactly the same thing. And the key here is we really need that negative 4 here. So we had the negative 4 in this case because we had a power of a negative 4. So when we brought it down, it became negative 4. Here, when we did the quotient rule, we had a plus and a plus, and then we had to subtract that one. Now this power was still positive, but a negative times a positive gave us that negative. All right, what about this one? Well, what does a cubed root of x look like? Well, that's equal to x to the 1/3. Well, what we have is ln of x squared to the 1/3. Okay, so, well, that's the ln of 2/3, or x to the 2/3, I should say. Okay, now that 2/3, that's the power, and so we can bring it down front, and we have 2/3 ln of x. So first we had to convert this cubed root of x squared, remembering the cubed root of x was x to the 1/3, and so we took x squared to the 1/3, multiply those, we get 2/3, bring that down in front using power rule, and we get 2/3 of 2/3 times ln of x. All right, what about this one? So it's a little more along the lines of what we just did with that cubed root, except now we have the square root. And so I think what I'm going to do is I'm going to break this up first. I'm going to say, well, this is the ln of, and then I'll put big parentheses, and I'm going to do factoring, and I'm going to simplify as much as possible. Well, down here, I've got the difference of squares, it looks like. So that's x plus 3, x minus 3. Okay, no problem there. Now I can take the square root of each individual piece here. And so that's going to be x minus 1. And if I write that as a power, that's to the 1/2. And that's times 2x plus 1 squared. And then that whole thing is to the 1/2. Okay. Well, 2 times 1/2, guess what? Those 2's cancel. And so I just have 2x plus 1 to the 1, which is just 2x plus 1. Okay. So now if I simplify, I really, just to get rid of that, I'm going to make it all in one thing. And I have x minus 1 to the 1/2, and then times 2x plus 1 all over x plus 3, x minus 3. And I forgot the in parenthesis there. Okay. Now what do? Well, now we can use the product rule and the quotient rule all together. And then after that, we can use the power rule. So going down here, I'm going to say that's going to be the ln of x minus 1 to the 1/2. And now since this is a product, I can say plus the ln of 2x plus 1. Now I'm dividing, so now I have to say minus the ln of x plus 3, and then minus the ln of x minus 3. Okay. Now I'm not done because I still have a power, so I have to go ahead and bring that down. And so that gives me 1/2 ln x minus 1 plus ln 2x plus 1 minus ln x plus 3 minus ln x minus 3. Okay. And so that would be the expanded form of that initial ln of the rational expression there. Okay, so we just simplified it as much as we can, and we have our final answer. All right, let's pause there and we'll come back for more.